review for the things that we've already talked about. For example, we've talked about parallel lines before. Remember how I used that symbol for parallel? The little slash things? Do you remember what was the definition? Why do we call lines parallel? What's the important thing about them when they're parallel? They don't cross, but the reason they don't cross is what do they have in common? Same what? Slope. Good, yeah. They have the same slopes. So parallel lines all have the same slopes. Okay? They have the same slopes. One of the other lines that we talked about, I don't know if you remember this or not, you can still have two lines that don't intersect, but they're not parallel. Remember the word skew? Skew lines? For example, if I look at that line in that upper right corner where the ceiling meets the wall, and then I have the line down over here on the floor, those two lines are never going to intersect, but they're not parallel because they're in different planes. Yeah. So just a reminder, skew are lines that don't intersect, but they're in different planes along those lines. But that means along those lines. Yeah, come on. But the idea here is that parallel lines, they all share the same slope because we're talking about algebra stuff here today. And then on the other hand of those, we had what were called perpendicular lines. And I'm assuming you guys have all seen that upside down T for perpendicular. What happens when lines are perpendicular? What's created?
They cross and make a 90-degree.
Perfect. They cross and make a 90-degree angle. And that's kind of why we use that upside down T to remind yourself that you see that little box. You can kind of draw on that little box there. Now, when they deal with their slopes, there's a relationship between their slopes as well. Now, parallel lines all have the same. Perpendicular have what are called opposite reciprocal slopes. It's not that. It's not. Even the sound of it, it's not. It's quite atrocious.
But you know how to say it? Spaghetti.
It.
No.
Supercalifragilisticexpialidocious. Even though the sound of it is something quite atrocious.
What?
It's the next line of the song. Anyway, what we're talking about here, what are called opposite reciprocal. The easiest thing to remember about that, then, guys, is that just means change the sign. So if it's negative, it becomes positive. If it's positive, it becomes negative. And then you flip the fraction. That's what that means. Opposite reciprocal means change the sign, flip the fraction. So we'll add to our list of things that we've been doing. We'll add to the list of things we've been working with algebraically here. Finding slopes, slope-intercept form, point-slope form, and then actually talking about slopes. So parallel lines, they have same slopes. And then perpendicular lines have what are called opposite reciprocal slopes. Okay. So by that idea then, if I say that you have an original slope, if my original slope is 2/3. A lot of times I will write out original, I just write ORG just to abbreviate it. It's a pretty common thing. Most textbooks use that too when you're trying to identify certain things. So if I say the original slope is 2/3, what's parallel to 2/3? Well, what do you know about parallel lines? Same slopes. So if the original slope is 2/3, what's parallel to 2/3? 2/3. Okay. Shh, please. What would be perpendicular to 2/3? 3/2, but what do you have to do to it? Change the sign, flip the fraction. Negative 3/2, yeah. That's what opposite reciprocal means. Change the sign, flip the fraction. Okay? Change the sign, flip the fraction. Same idea. If I have an original slope, let's say it's -4. If I have an original slope of -4, what's parallel to a -4? It would be the same thing. It's -4. Then, change the sign, flip the fraction. Positive 1/4 again. 1/4. Remember, when you have a whole number, guys, it can always be written as 4/1. So you just flip it, and that's where you get that 1/4. Okay. That's kind of what we're getting at here. The weird stuff with these things come into play when we start talking about specific styles of lines. And when we talk about specific styles of lines, we're really only talking about two types. We're talking about horizontal ones, and we're talking about vertical ones. And this, for some odd reason, has always been one of the things that most students have the hardest time to grasp the idea of what's going on. Okay? So, when you're looking at a horizontal line, if you're not writing something down, you're just kind of shooting yourself in the foot with this, because this does get complicated. You kind of want to know how to do this to pass this stuff. Okay? So make sure if you need paper, there's plenty in the back. Go grab some. So horizontal lines. Which way do horizontal lines always go? They go left and right. Yeah, horizontally. Yeah, thanks. So horizontal lines always go left and right. We talked about this the other day. Whenever we graph horizontal lines, what value doesn't change? Bring the front. What value doesn't change with a horizontal line? The y value. The y value never changes for every horizontal line. It just moves left and right. When you're moving left and right, you're changing your x values. Your y values never change. That means then, like we said earlier, let me get rid of this now. Like we said earlier, every horizontal line has the same equation. Y equals some number. Every horizontal line also has the same slope, because all horizontal lines are parallel to all horizontal lines, and that means they have to have the same slope. What was the slope of every horizontal line? 0. Good. And the dumb way that we remembered that is, what's the second letter in the word horizontal? Oh. Okay. All right. Now, when you look at your papers, can I steal your paper real quick? Thanks. When you look at your, so when you're looking at your papers, you guys have all these blue lines going left and right. All those blue lines are all horizontal to each other. Okay. Will those blue lines ever intersect each other? No. Unless you start ripping up the page. Sure. So the idea here is that you're looking at your answers to all of this stuff. The y value never changes. Know how you would number your lines? 1, 2, 3, 4, 5, 6, 7. Y equals 1, y equals 2, y equals 7, and so on and so on. You're doing that idea here that going all the way across. Okay? So every horizontal line, we know then that horizontal lines are always parallel to horizontal lines. Okay? What's the equation of a horizontal line always going to look like? Y equals something, isn't it? So that means that y equals a number is always parallel to an equation, y equals a number. Because again, what's the slope of every horizontal line? 0. So that means that if you have a slope of 0, what's parallel to a slope of 0? 0. Okay? It seems too easy to be true. Okay? It seems too easy to be true, but that's what takes time for students to kind of wrap your head around it. Because they're used to counting up and down for your y values, which is correct, because that's the y-axis. But when y equals a number, that value stays constant throughout. And that's what's weird to start with. So, horizontal lines are always parallel to horizontal lines. That means that y equals a number is always parallel to y equals a number, because the slope is 0, which is parallel to a slope of 0. I'm going to come back to using this here in a couple minutes, but for right now, I just want to write that out. Okay? Not terrible? Please don't do that. All right. What's the slope of all vertical lines? We did that the other day. When you have a vertical line, well, they all have numbers. Shh, ladies. Well, if the slope is 0, it would be a horizontal line, wouldn't it? Well, then if y equals a number, wouldn't that be a horizontal line? That's why we just define that. X equals a number. Every vertical line has the same equation. It's always x equals a number. So think about your slope equation then. If the x value stays the same, and you're doing your slope, the change in x, well, if these two numbers are the same, if it's x equals 3, what's 3 minus 3? 0. Can you divide by 0? No. That's why vertical lines all have that slope that is undefined. Okay? Slopes of vertical lines are all undefined. That means you have 0 in the denominator. Slopes of horizontal lines are 0 because you have 0 in the numerator. That's the difference between the two. Now, back to your notepads. On your notepads, you've got that red tab line here. You got another red tab line on the other side too, don't you? Reddish, pinkish, whatever. Will those two lines ever run into each other? No. That means vertical lines are always parallel to each other, vertical lines. Same idea. Vertical lines are always parallel to vertical lines. And if you break that back down, it's the same idea like we did with horizontal. If horizontals were y equals a number, verticals were then x equals a number. So if vertical is parallel to vertical, x equaling a number has to be parallel to what? Thank you, good number, very good. All right, which means the slope, if the slope is undefined, what's parallel to undefined?
0?
No. Remember,
Undefined.
parallel lines have the same slope.
So
Undefined. So that means if your slope is undefined, you're parallel to other undefined slopes. That means all vertical lines are parallel. All right? That's how that works. So I write that out. Vertical are parallel to vertical. That means x equals a number is parallel to x equals a number. Slope is undefined is parallel to slope. Oops. That's undefined. Those things are stuff that you guys did back in algebra. You just probably don't remember it because it's been a while. Now, going back to your paper, all these blue lines that are horizontal to one another, that one red tab line on the left-hand side, what is that red tab line to every single one of those horizontal lines? It's 90 degrees, so they're all perpendicular, right? Which means, aren't horizontal lines perpendicular to vertical lines?
Oh, you could cross.
Well, they can cross anywhere. You can have a line just cross like this, but they don't have to be perpendicular, right? But more specifically, yeah, and more specifically, the slopes work. Okay? So, what was the equation for every horizontal line? That slope. What's the equation? Y equals a number. That's the slope. Okay? You're on the slope there. So it's always y equals a number. What's the equation of every vertical line? X equals a number. Okay? They're meant to be, exactly. What's the slope of every horizontal line?
0.
0. That means that your slope of 0 is always perpendicular to the slope that's undefined. That's what that means.
Right.
Horizontal and vertical are perpendicular to one another. Horizontal is perpendicular to vertical. So y equals a number is perpendicular to x equals a number. Slope of 0, oops. And then just one quick reminder, this can be flip-flopped. Vertical is perpendicular to horizontal. You can say it either way, it means the same thing. But you just don't write it out that fourth way, it's just based on it. Now, the reason that I say these things to show you this is because as you go through in, like today, we're going to be writing equations of lines that are parallel, write equations of lines that are perpendicular. Horizontal and vertical lines are the easiest ones to write equations for. They always have been, because it's either x equals a number or y equals a number. You just have to know which one you're dealing with. So if I look at one, for example, if I say y equals -3, is that a horizontal or a vertical line? It's horizontal, because it's y equals a number. So let's say I have y equals -3, and I want you guys to write the equation that is parallel through the point 4, 6. That's the kind of stuff we'll start to do. Y equals a number is what kind of a line? It's horizontal. What's parallel to horizontal lines? Horizontal lines. And what's the equation of every horizontal line?
0.
Y equals
Y equal, that's you're thinking slope. Slope is 0. What's the, that's not a horizontal line. If you unplug your earbuds all the way so you can hear me better, like take them out maybe. I didn't know if you have inside of you. I didn't know, oh, you do have inner ears. You know you had those. And then maybe write and maybe you can also write some of this down too if you go for it. So again, the idea here is y equals a number is a horizontal line. What's parallel to y equals a number? Y equals a number. Well, what does y equal in this ordered pair?
6.
6.
And that would be your answer.
Oh, wait. So it would be like, since that's y equals
No. What kind of a line is y equals -3?
Oh, y equals a number.
It's y equals a number. It's a horizontal line. What kind of lines are parallel to horizontal lines? What's the equation? What's the equation of every horizontal line? Y equals a number. So what's parallel to y equals a number? Y equals a number. What's y equal in that ordered pair? 6.
So the -3 is the
That's just telling you that it was a y equals a number. Okay? Same idea.
Okay.
I'm glad, because a lot of times people have the worst time trying to figure this out because they overthink it. X equals a number is what kind of a line? Vertical. What's parallel to all vertical lines? Vertical lines. What's the equation of every vertical line? X, that's a slope. X equals a number. So x equals a number tells me it's a vertical line. What's parallel to a vertical line? Another vertical line, which is x equals a number. What does x equal in that ordered pair? Almost.
This would be some sort of attitude.
Okay. Try another one.
Oh, okay. It'd be 2. It'd be 1. Yeah, it'd be 1. Okay.
Y equals a number. Is this y equals a number?
No. Yes. It's obviously enough.
What does y equal?
-7.
-7. According to this, it says y equals -7. What kind of a line is y equals -7? No. What kind of line is y equals -7?
Horizontal.
Horizontal. Okay. It then asks what's perpendicular to it through the ordered pair to 1.
X equals 2.
Okay. What's perpendicular to horizontal lines? Vertical lines. What's the equation of every vertical line?
1.
It's not 1. X equals a number. What is x equal in this case? 2. But yes, you said 2, but you didn't say tell me what was 2. Yes, ma'am. Yep. It does, and there's an electric one in the back too if you want to use that one. I don't know if that one's been replaced a couple times. Usually those things are pieces of junk.
Right.
All right. This is a really weird idea for people to think about because we're doing this conceptually versus formulaic. It's easier to think of this than just try to do some formula. Y equals -7. Well, that went through here at -7. Okay. The ordered pair that we have is what? 2, 1. Is that right? 2, 1. That point. I want to go through this point to be perpendicular here. Well, that means it's a vertical line that goes through that. What's the equation of every vertical line? X equals a number. What did x equal here? 2. That's what that looks like. Okay? It's a quick way of doing these things. We'll do another one here in a minute. But what changes, though, is what happens if I have, I want to write the equation, oops, it's a Q, not a G, that is parallel to y equals 2x minus 3, and it goes through, move this over a little bit, it goes through the ordered pair, -3, 6. Now there's more stuff involved. When there's more stuff involved like that, as opposed to stuff like this, what we do is we make it into 3 easy steps. Oh, no, we're not doing any of that. Okay? I think you guys, there's other people have been doing that, saying that same thing, and I don't know if it was some other weird, you guys might be thinking something different right now. What I'm trying to do here is, we're going to write another equation. So that way the 2 lines there's 2 different linear equations of them. So there's 2 different graphs that we can do. Now, when we do this, ladies, there's always 3 steps that we're going to follow. The first step is to always identify what is the original slope. In this equation, is x part of the slope? 2 is the slope, thank you. So in this problem, first thing I do, and I'm always going to write these steps out so you guys want to do step 1, step 2, step 3. It forces you to do the problem correctly. What is your original slope? In this problem, it is what? 2. Okay? My original slope is 2. After that, my second step is to reread the question and ask ourselves, is this a parallel problem or is this a perpendicular problem? Which one is it? It's parallel. The reason why I ask you guys to do that second step is it's really obvious when you start seeing the problems themselves. The problems themselves, you'll have 3 or 4 questions in a row that are parallel, and then the instructions change and says these next 3 or 4 are perpendicular. After you guys do 3 or 4 of the same problems, you think that all of them are the same problem to do. It happens all the time. This way, it makes you stop for 3 seconds and reread, is this a parallel or perpendicular problem? And then you go on your way. Is this a parallel or perpendicular problem? Yeah. Parallel, okay. So in this step, we write down what's parallel to a slope of 2. 2, okay? Our third and final step is kind of like 2 parts in 1. Because it's parallel. If it's perpendicular, we would have done something to it. So here, we would use point slope form now, like we've been doing. Oops. With our new slope, and the ordered pair we were given to solve for y. Okay. So now we use point slope. Yes, ma'am. We use point slope almost all the time. Yeah. So you've got your point slope. When we write it out, then after that, you've got your slope that you knew. And I think the ordered pair was what? -3, 6. So I'm just going to rewrite that down here. Was that -3 and 6? So I start filling in the blanks. Well, that means it's y. Our y sub 1 is 6. Our slope is 2. Our x sub 1 is a -3. Very good. So whenever we have minus and negative, we always change it to a +3. And now what's left? Distribute and solve for y. Okay, we distribute and solve for y. Yes, ma'am. There's just 3 steps. You use the point slope form with what you have, substitute in, and solve for y. I mean, it sounds like there's more to it, but you're just doing the same thing we have then. How do I move that -6? You meant subtract the negatives with it, right? It's not as much. And you're left with y equals 2x plus 12. And that would be the equation of the line. Now, this may be a little bit different from what you guys, or how you guys did this, like a step-by-step approach in Algebra 1. I've been using this method forever. I like writing out steps, showing where everything's going, because it keeps everything in a very sequential, do this, do this, do this step. It's very formulaic, all right? Yeah.
I'm sorry.
Should be. Okay. We'll try another one here in a second. Good? All right, let's try another one. So, same instructions, we're going to be parallel to the equation y equals -1/2 x minus 4, and we'll say we're going to go through your ordered pair of -6 and 7. Obviously, some of the worksheets and whatnot won't just have little slash marks for parallel. It'll write out the words, write the equation of the line that passes through a certain point that's parallel, so on and so on. I'm just shorthanding it real quick so we can get through some examples. Your first step is to, what is your original slope? -1/2. The reason why I also say that we have to figure out our original slope is, you know how yesterday we had stuff that looked like this, where 2x minus y was 4? And you had to solve for y? Same idea, you'd have to get y by itself to identify the original slope. So that's why we always do that first. Yeah?
How would you know if it's imperial?
It'll tell you. It has to tell you. I just, for right now, instead of me writing out all those words like the instructions would look like, I'm just putting a symbol in there. I'll show you here in the next slide of what the words look like. Okay? I'm just trying to shorthand it. You guys said your original slope was what again? Okay. Step 2, is this a parallel or a perpendicular product? It's parallel because it says parallel. What's parallel to a -1/2? -1/2. Okay? So it's going to be the same slope. It's -1/2. Lastly, bless you, we have our point slope form. And our ordered pair, I forgot, was 6. Was it -6? Yeah, -6 and 7. And our slope that we're using is -1/2. We just substitute in. So it's y minus 7 is -1/2 x plus 6. Good. And then we just distribute. Multiply everything inside the parentheses by your -1/2. We get y minus 7 is -1/2 x. What's -1/2? Very good. And what do I do with my 7? Add it up. Yep. It's really not any more complicated than anything we've been doing. It's just adding those couple of steps thrown in there about what's your original slope, what's your perpendicular slope, things like that. Okay? So you were asking a second ago, what does it look like? How do you know what it looks like in terms of parallel or perpendicular? You're going to get stuff that reads like this. And don't write this down. We're just going to do an example off this. See how it says, write an equation of the line that passes through point P and is perpendicular to the line with the given equation. That's what your instructions will always look like. It will tell you perpendicular. It will tell you parallel. It won't have the little symbols in there usually, unless it's something I write out or type in. Because that's too many letters to type. Okay? So you'll always know what you're doing. This P, it just says through point P. It doesn't mean that's parallel. It doesn't mean it's perpendicular. It just means it can see point C, be point A. It doesn't matter. Okay? So if we do this one here, where it says, write the equation of the line that's perpendicular through the equation. Through that point, we want to write the equation of the line that's perpendicular through the point 520. That's perpendicular to the equation y equals 1/2 x plus 8. We still follow the exact same steps. What's your first step? Find the original slope. So, step number 1. My original slope is 1/2. Good. Step number 2. Is this a parallel or a perpendicular column?
Perpendicular.
It's perpendicular because it says perpendicular. So what is perpendicular to 1/2? -2. Change the sign, flip the fraction. Remember, perpendicular slopes have opposite reciprocal. Change the sign, flip the fraction. So perpendicular to 1/2 is -2. And then your last step is the same. Use point slope with that given, or with your new slope and the given point. So yeah, y minus 20, good, 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 go ahead. So it's y minus 20 equals, perfect. Everybody hear that? Y minus 20, because your y sub 1 was 20. Your slope was -2, and your x sub 1 is -5. I'm sorry, not -5, is 5. So you fill in those blanks, and then guess what you got to do now? Solve for y. Distribute and solve for y. You distribute and solve for y. And then we add 20 coming back. It can be infinite. It doesn't matter. There's no set reason for how big a y or an x-axis can be. It can be anywhere. I mean, if I'm having you graph stuff, if I have you graph something, I'll usually have you graph stuff within a 10 by 10 realm because it's easier. That way I don't have to try and scale it. But I know, like right now in my Algebra 2 classes, we're graphing stuff that have really crazy intercepts, and I have them scale it on their own. So, like the intercept here is at 80, they write 80, 0. If the intercept here is at 120, they just call that dot 0, 120. What's halfway between 0 and 120? 60. So I know 60 would be about here. If 40 is about halfway here, would 20 be about here then? So they learn to scale it themselves. But with you guys and with Algebra 1 classes, we tend to try and keep, if we're going to graph something like this, it would normally fit on a 10 by 10 grid. Okay. Is that what you're kind of wondering about? Yeah, don't worry about graphing something that big. Okay. But yeah, we do a lot of scaling later on once you guys get into the upper levels. Let's see, there was one other in here. We'll do this one real quick. And we'll just leave this one here. This is another perpendicular. Your equation is, take a minute, I want you guys to try this one on your own. Your equation is y equals -1/3 x minus 6 And I want you to be perpendicular through the point 4, 5. Okay? Write out and show those 3 steps because it makes your life easier as you fill them through. All right? It makes everything easier as you fill all those through. What's up? Yes, sir.
Did you ever meet the French?
I never met him. No. It's very sad. I met.
The French.
Wait, did he pass away though?
No, he's still alive.
Oh.
From the 85 Bears, they lived up to when they won the Super Bowl back in 85, 86. The next couple of years, they used to do like charity basketball events and stuff at high schools. And at the time, I was living in McHenry, and I want to say it was maybe my sixth or seventh grade. A couple of the players came out and did a charity basketball game against the high school basketball team, and you could stand in line to get an autograph, but my God, there had been thousands of people trying to get autographs with these guys. So I've got a couple of pictures, like in a gym, like taking a picture. It wasn't the fridge. I think it was Dan Hampton and Matt Suey, I think, was there. It was just a couple of the guys. They played with the coaches. But I never met. I have yet to meet the Fridges because he's not dead. Lastly, first thing here, real quick, if I go through this, what's my original slope? What's perpendicular? Shh, guys, we gotta go through this. What's perpendicular to negative 1/3? 3. From here, is it okay if I know how to use point slope form to start filling in the blanks right away? Is there any rule against that? No. If you're comfortable doing that, go for it. After that, you distribute and solve for y. You did this right. You get 3x minus 12 plus 5. You get minus 7. I have 6 of these for you. 3 of each style. I tried to get the books up to work, but it wasn't showing up for everybody. So I made a quick little picture of it. It's not the cleanest of little pictures, but you should be able to figure out what they're asking you. The first 3 are parallels. The next 3 are perpendicular. Why? Because it says so. There's just 6 of them on there. The numbers are completely irrelevant. What I would do on this, there's obviously not enough room underneath each one of these columns to do your 3 steps, but you could probably do it on the back. All right? Does that make sense? I already told you one of my steps there. All right?